Have you ever stopped to think about how that TV show you're watching is literally being beamed down from space? It's pretty wild. It's this epic two-way conversation that stretches across thousands of kilometers, a constant back and forth between the ground and the sky. So let's actually trace that signal's journey, both up and down.
So here's the first thing you really gotta get. A satellite isn't a talker, it's a listener. It doesn't create anything. You can think of it more like a giant, super smart mirror floating up in orbit. Its whole job is to catch a signal sent from Earth, give it a massive boost, and then bounce it right back down to us.
Right, so this mirror in the sky, it's not a one-way thing, it's a two-way street, a constant flow of information going from Earth up to space and from space back down to Earth.
Now, the first half of that journey is called the uplink. And the name says it all, right? This is the signal being sent up from a big antenna here on the ground to the satellite. It's the outgoing message, Earth talking to space.
And of course, what goes up has to come down. And that, you guessed it, is the downlink, the signal's return trip home. Now, this all sounds pretty simple, but here's the twist. The journey up and the journey down are completely different animals.
All right, let's get into the good stuff. We're going to follow a single piece of information, let's say it's your favorite TV channel, on its full, mind-boggling trip from a studio all the way to your living room.
Okay, so here's how it works. It starts at an Earth station where that TV show gets turned into a high-frequency signal. Then, step 2, that signal is powerfully blasted up into space. That's our uplink. The satellite, way up there, catches this now incredibly faint signal, gives it a boost, switches its frequency, and then sends it back down. That's the downlink, which your little satellite dish at home can pick up.
And think about this for a second. An Earth station is literally screaming this signal into space with an enormous amount of power. But after traveling, 36,000 kilometers, it arrives at the satellite as just a tiny whisper. The satellite has to pick that one faint whisper out from all the background static of the entire universe. It's an incredible challenge.
And, how the satellite deals with that whisper makes a huge difference. The older, simpler ones are basically just mirrors. They grab whatever they hear, make it louder, and send it back down, mistakes and all. But the newer, smarter satellites, they actually listen to the message, decode it, clean it up, fix any errors, and then send a brand new, perfect copy back to Earth. It's the difference between a faint echo and a fully remastered track.
So we've got the trip up and the trip down. You'd think it would be a perfectly symmetrical journey, right? Well, it's not even close. The uplink and the downlink are fundamentally different, and for some very, very smart reasons. It really boils down to 4 huge differences. First, they're not even talking on the same channel. They use different frequencies. Second, the power levels involved are worlds apart. Third, the gear is completely different. And fourth, they even face different challenges, like something as simple as a rainstorm.
Okay, so let's dig into that first one, because it's a biggie. Why on earth can't a satellite just listen and talk on the same channel? Why complicate things?
Well, here's the main reason, and it's actually pretty simple when you think about it. Imagine trying to listen for a tiny whisper while you yourself are shouting at the top of your lungs. It's impossible. The satellite can't listen for that faint uplink signal if it's blasting out a powerful downlink signal on the same frequency. So they use different frequencies to keep the two conversations from interfering with each other.
And you can see that exact pattern right here. It doesn't matter what band you're looking at, C, Ku, Ka, the uplink frequency is always higher than the downlink. The reason for that is pretty cool. Higher frequencies take more power to push through the atmosphere, and down here on Earth, we've got plenty of power to spare.
And let's talk about that power, because this is where the difference is just mind-blowing. An Earth station is plugged into a massive power grid. It's a powerhouse. A satellite, on the other hand, is basically running on a couple of really good solar panels. That's the staggering difference in resources we're dealing with.
And that power difference is, well, it's everything. Honestly, the downlink is almost always the weakest link in the chain, the system's biggest bottleneck. The single greatest challenge for satellite engineers is figuring out how to get a strong, clean signal down from a satellite that's basically running on a battery.
Okay, so that's enough of the technical stuff. Let's bring this all back down to Earth and look at how this plays out in the real world, with something you probably use every day. Let's go back to satellite TV. A TV station uses a massive, super powerful antenna to send all its channels up to space. That is the uplink. The satellite catches it, boosts it, changes the frequency, and then broadcasts it back down over an entire continent. That's the downlink. And that one powerful uplink can serve millions of tiny dishes on people's homes. It's an amazing system. But, this incredible journey isn't instantaneous. Even traveling at the speed of light, that round trip from Earth to a geostationary satellite and back takes about half a second, 500 milliseconds. And that little delay, what we call latency, is exactly why satellite internet can feel a little slow sometimes, especially for things like online gaming. It's just the physical price you pay for talking to space.
So what's the big takeaway from all this? It's that the whole conversation starts right here, on the ground. It's a powerful shout up into the void, followed by a very carefully managed echo that comes back down to us. When you boil it all down, in satellite communication, Earth always does the talking first. Space just listens, amplifies, and replies.